Well, tachyometric surveying. Uh, Here you can see some useful links. I also copy this link. Sorry, it does not work. In slideshow mode, here you let me share with you some useful links. And this one. Well, today um, I am going to speak about tachyometer, tachyometric surveying, classification of different survey methods, principle of stadium method, distance calculation by stadium method, and elevation calculation by stadium method. Well, what is tachyometry? It's easy and cheap method of collecting much topographic data. Tachyometry, or in another spelling, tachyometry, also called uh, stadia surveying, in countries like England and the United States. It means fast measurement from Greek language. Tachyo means quickly, and metri in Greek means measure. So it's a rapid and efficient way of indirectly measuring distances and elevation differences. Here you can see another explanation, branch of surveying in which both horizontal and vertical distances between stations are determined from instrumental observations. Um, the tachyometry method of tachyometry, you need no slope corrections, tensions, since no chaining involved. Uh, rapid, it is rapid and convenient. Tacheometric surveying is good for rugged terrains with deep valleys, mountains, across water bodies. However, this kind of surveying has not very high accuracy. Main purposes of the surveying is preparation of contour plans with details, widely used in preliminary site location for railways, roads, canals, reservoirs, etc. The geometric surveying we use uh, with taking angular observations with an instrument known as tachyometer. We do not use chaining. Um, so we try to measure the distance indirectly. The method is adopted in rough and difficult terrain where direct leveling and chaining are either not possible or very tedious. It is also in location survey for railways, roads, reservoirs, etc. Here in the slide you can see um, tachyometer rods or tachyometric staff and the tachyometer itself. Tacheometer is a transit theodolite fitted with stereo diaphragm and analytic lens. Analytic lens means convex lens. Additional convex lens is provided between the eyepiece and object glass at a fixed distance from the object glass. The purpose of providing analytic lens is to make additive constant f plus d exactly 0. Here you can see how the different kind of tachyometer rods or stuff looks like, and the hair crosses in the object glass when you are looking through telescope into the object glass. You can see different kind of hair crosses. The concept of tachyometry uh, to determine distances indirectly using triangle geometry. First and most common method is Stadia method. It's establish constant angle and measure length of opposite side. Length increases when distance from angle vertex increase. What does it mean, Stadia system? The theodolite or after level is directed at the level staff, and the distance is measured by reading the top and bottom Stadia hairs on the telescope view. You can see point O, it's the instrument, and the Stadia hairs, up hairs and bottom hair, the angle between these hairs is constant. So while moving a rod much closer or on the longer distance, the picture of these study hairs are projected onto the picture of the rod, and we can easily calculate the number of centimeters on the rod between these hairs. And if the rod is closer, the stadia hairs intersects on a rod smaller distance. And while we move the rod uh, further, the number of centimeter marks on a rod uh, become mm, much more big. In the first type of distance between the two, there are two types of instruments used for stadia surveying. Stadia hairs in the theodolite telescope is fixed. This situation you can see in the picture. In the second type of equipment, the distance between the stadia hairs is variable, being measured by means of a micrometer. The most common method used involves the fixed hair tacheometer or theodolite. Another option is electronic modern technique, which use electronic tacheometer. We use a total station which contains an electronic distance meter able to read distance by reflecting of a prism. Another option is substance bar system. It's an accurate theodolite reading to 1 second of arc. It is directed at a staff, two pointings being made, and the small subtended angle measured. The size of this bar system is 2, 3, or 5 meters. Well, the main instrument for tachyometric survey is tachyometer. It is similar to a theodolite, fitting with stadia hairs to the eyepiece. The stadia diaphragm consists of one stadia hair above, upper stadia, you can see, and the other equal distance below the horizontal crosshair. They are kept in the same vertical plane. Uh, as the H and V crosshairs. A stadia rod is a graduated rod. The leveling staves can also be used. While in the past distance were measured by the surveyor's chain, this can be done easier and faster using a telescope equipped with stadia hair lines in combination with a stadia rod after level and stuff is another option. The stadia diaphragm is a fixed aperture with two horizontal lines or crosshairs located within the objective lens of the instrument. The diaphragm is positioned so that the two horizontal lines are at a known distance apart, typically around 1 meter. When a surveyor looks through the instrument, they will see the crosshairs of the stadia diaphragm and a distant target such as a prism or staff. By measuring the distance between the two horizontal lines on the stadia diaphragm, and then measuring the distance from the instrument to target, the surveyor can use trigonometry to calculate the distance from the instrument to the target. Uh, so we have upper hair, lower hair, and middle hair, and which are crossed by vertical hair. However, there are different forms of stadia diaphragm that commonly used, but much common is classic um, three hairs system. Mm, here you can see the crosshairs in the bigger scale. We have some vertical crosshair, lower stadia hair, horizontal crosshair, and upper stadia hair. Uh, Here you can see the telescope tube and crosshair ring, which allows to see the crosshairs in focus, and capstan headed screw for improving the uh, crosshairs position in a tube. Well, the stadia diaphragm works on the principle of the stadia method, which was developed in the 19th century as a way to measure distances quickly and accurately in the field. The stadia method uses the fact that the size of an object appears smaller the farther away it is. By measuring the apparent size of the target, as seen through the stadia diaphragm, and knowing the distance between the crosshairs, the surveyor can calculate the distance to the target. Overall, the stadia diaphragm is an important component of the stadia theodolite, which is an versatile and precise surveying instrument used to measure distances, angles, and elevations in geodesy and other fields of surveying. Tacheometry and its characteristics. Tacheometer is a transit theodolite fitted with stadia diaphragm. Telescope should be fitted with an analectic lens. Magnification power of the eyepiece is kept high. Value of multiplying constant K is equal to 100. Value of the additive constant C is 0. Mm, Stadia rod, it's also called as staff or vertical stave. It is a 5 to 15 meter long rod for distance more than 100 meters. It can be held vertical or normal to the line of sight. Well, transit theodolite is a surveying instrument that is used to measure horizontal and vertical angles. The transit theodolite consists of a telescope mounted on a tripod with a graduated circle or protractor attached to the base. The telescope is mounted so that it can rotate horizontally or transit, and vertically or tilt around a vertical axis which is perpendicular to the horizontal circle. The transit theodolite is used to determine the angle between two points on the ground or in the sky. The surveyor sets up the instrument over the first point and sights through the telescope to a second point. The horizontal circle is then turned until the telescope is pointing directly at the second point. The angle between the 2 points can then be read on the graduated circle or protractor. The transit theodolite can also be used to measure vertical angles such as the elevation of a point on the ground or the height of an object in the sky. To measure a vertical angle, the telescope tilted up or down until it is pointing at the point of the interest. The angle can then be read on the vertical circle which is attached to the telescope. The transit theodolite is an important tool in geodesy as it allows surveyors to make precise measurements of angles which are used to calculate distances, elevations, and other parameters. Transit theodolites are still used today, also they have largely been replaced by more modern instruments such as electronic total stations and GPS receivers. Uh, well, tachymetry is defined as an optical distance measurement method. Um, as compared to chaining or flat grounds, the accuracy of tachyometric distance is low, but on roof and steep grounds the accuracy is more. Here you can see the sketch of the instrument. Uh, then it is the height of the instrument, the vertical angle, the stadio lines, and other components of a measurement, distance between the instrument and a rod, and the height difference between point P and point X. We use tachymetric surveying to measure horizontal distance, which can be measured by tape or chain in the hilly area, or measure vertical distance by angular observation. Here is the horizontal distance, and here is the vertical distance. In difficult areas where leveling and other types of surveys are tedious or conduct, it's suitable for overcoming obstacles such as roof and broken ground, deep rivers, ponds, etc. We use it for preparing counter plans, for conducting hydrographic and land survey, for traversing in difficult terrain. We have a few methods of tachymetry, mainly of two types, stadia and tangential method. And the stadia method is divided to fixed hair method and movable hair method. The stadia method in the diaphragm is provided with two stadia hairs. Fixed hair method, the distance between stadia hairs is fixed in this method, which is the one commonly used. When the staff is sighted through the telescope, a certain portion of the staff is intercepted by the upper and lower stadia. The value of the staff intercept varies with the distance. However, the distance between the station and the staff can be obtained by multiplying the staff intercept by the stadia constant. Commonly, the stadia constant is 100. So, if we see difference between upper and lower stadia hairs about 20 centimeters, it means that the horizontal distance between an instrument and a rod and the rod is 20 meters. The tangential method, in this method, the diaphragm of the tachyometer is not provided with stadia hair. The readings are taken by the single horizontal hair. Here in the slide you can see comparison of two methods. Well, once more, the study in the method is the most prevalent method for tacheometric surveying. In this method, the telescope of the theodolite is equipped with two additional crosshairs. These additional crosshairs are known as study hairs. The tangential method of tachyometry is being used when study hairs are not present in the diaphragm of the instrument. Nowadays, I have not seen any instrument without stadia hairs. So, this tangential method, the staff sided is fitted with two big targets spaced at a fixed vertical distance. Vertical angles corresponding to the veins, say theta 1 and theta 2, are measured. The horizontal distance, say d, and vertical intercepts, say v, are computed from the values as predefined divided by known theta 1 and theta 2. This method is less accurate than the Starian method. And nowadays, is very rare. Well, fixed hair method of tachyometry. Here, the stadia hairs are kept at fixed interval, and the intercept on the stadia rod varies depending upon the distance between the staff and the instrument station. Why the distance on the rod is I1, the distance between instrument and staff is D1, I2, D2, I3, D3. Fixed hair method of tachyometry. The intercept is determined by subtracting the lower study reading from the upper. When the staff intercept is more than the length of staff, only half of the intercept is used between the middle hair crosshair and upper or lower study hair. Then have multiply by 2. Well, staves must hold vertically to get an accurate measurement. Horizontal and vertical angles are read to the middle hair. Various wires, in addition to the cross wires or cross hairs on the diaphragm, are known as stadia wires. Uh, so, different instrument allows us to keep the parallactic angle A or alpha defined with the help of stadia wires or hairs fixed, and another option, uh, the parallactic angle is changing, and we can measure this angle. Another way used to make observation is keep the staff intercept fixed x AB and uh, distance and h strich b strich. So the equal marks on a road on different distances between the instrument and the road will be intersects uh, by different parallactic angle. In this method, stadia wires will have to be moved and accordingly called as movable hair of subtils method. Here you can see formula of stadia method. D1 distance is L1 divided to tangents of half an alpha angle, and also divided by 2 or multiplied by 0.5. The distance 2 is equal to this formula. Study readings. We use middle hair to read a vertical angle, and upper and lower hairs readings we use to measure a distance. Here we can see the principles of study method. A and B mm, are rod intercepts, small A and B stadia hairs, S rod intercept, F principal focus of objective lens, uh, uh, small f focal length, I stadia hair spacing, C distance from instrument center to objective lens center, C stadia constant, K stadia interval factor, D distance from local focal point to rod, D distance from instrument to rod. Here you can see uh, study equations from similar triangles d divided by f is equal s divided by I. So d can be calculated f divided by I and multiplied by s. So horizontal sides h is equal ks plus c. Usually k is 100 and c is equal to 0. So the h horizontal side or distance between instrument and rod is s multiplied by 100. For inclined sides, h is equal to ks cosinus alpha plus c cosinus alpha. Another formula is h is equal to 100 s cosinus alpha. And vertical distances can be calculated by with these equations. The notes below show the calculation of distance d from the center to the fixed hair tachyometer or target. It's another example of the picture and the repetition of the formulas. Well, is it clear the how does study principles work?
Yes.
Yes, no? Well, Uh, AB distance is obtained by subtracting the readings given on the staff by the lower stadia hair from the top one and is usually denoted by S staff intercept and small a and b, the distance apart of the stadia lines is denoted by I. This value I is fixed, known and constant for a particular instrument. The reduction of this formula would be simplified considerably if the term f divided to I is made some convenient figure and if the term f plus c can be made to vanish. Constant determination. In practical, the captive constant generally equals 100 and the additive constant equals 0. This is certainly the case with modern instruments by may not always be so with older theodolites. The values are usually given by the makers, but this is not always the case. It is sometimes necessary to measure them in an old or unfamiliar instruments. The simplest way both for external and internal the simplest way both for external and internal focusing instruments is to regard the basic formula as being a linear one of the form. On a fairly level side chain out a line 100 to 120 long, setting pages at 25 to 30-meter intervals. Set up set it up at one end and determine two distances using tachyometer or theodolite, one short and one long. For instance, hence C and Q may be determined. Where the instrument designed with an analytic lens, the additive constant K is equal to 0. According to the stated principle above, you can see the proportion of distances and proportion of all this theory of study of tacheometry. Uh, Here you can see the formula for horizontal and vertical distances determination. Uh, Above equation is tachyometric distance equation. K and C are the multiplying and additive constants respectively. The multiplying constant is also called the stadia interval factor. Its value depends upon the stadia interval and the principal local length of the objects. For ease of calculation in distances, the stadia wires are spaced with such that the multiplying constant is equal to 100. The additive constant, practically speaking, is a constant value for a tachyometer because the value of d varies by only a small negligible amount when focusing the telescope on different objects. Value of C ranges from 0.25 or 0.35 meters. If an analytic lens is used into the telescope, it is so placed that all the reduced to the center of the instrument and the constant C becomes zero, and the tachyometric distance equation is simplified as G is equal to Ks. Hence, if the stop intercept is known, the horizontal distance can be really obtained by multiplying it by 100. Well, here you can see an explanation of fixed hair method. The easiest case if uh, when line of sight is horizontal and stuff is held vertically. Uh, the multiplying constant f divided by r is 100 and additive constant f plus d is generally 0. Here you can see hi is the height of instrument, and BC is BS is backside. Well, um, because of air sirens attention, mm, because of air raid sirens in Kiev, mm, the our election we stopped our election and continue it later. The number of slide is 44. Uh, thank you for your attention.